Okay, I think we are live.
Yeah, it's recording, so it's working well. The attendees coming, start coming. Hi, Luis. Hi, Martin. Nick.
Welcome back, everyone.
New faces on the screen. Well, there is Alfie, Damian, Guille. We will move Guille here.
Again, guys, in the chat, please mind checking panelists and participants and attendees, because if not, you will only speak to panelists. So,
hello.
Hi, Guille. How are you?
Fine, thank you.
Okay, we can hear you. Okay, so internet is okay. Well, welcome again. I wish you have a great night and day for some of you. Here in Argentina, it's early in the morning, so the day is starting. Well, we will wait. We will wait some minutes before starting in order to have all involved. So, as John said, please remember to chat with all also panelists and attendees, and well, be prepared. Well, I can see new names for the day. Hi, Noel. How are you? Hi, Guy. Again, happy to be with us.
I think we can wait 4 or 5 more minutes before starting, and then you can start sharing your screen, Manuel.
Yeah, okay. We will wait until maybe 4 more minutes, and then we will start.
Manuel, you can check your mail if you for the presentation. Good.
Great.
Thanks.
Thank you, Nick. Well, I think we are ready. We can start with the session. So again, welcome. You are very welcome. Nice to see you. Nice to have no children crying in the back, so we can have a good session for the moment. I know some of us are in this world. So, well, the idea of this session is to give a moment for the people involved in this group to show what are they doing, and also try to discuss about what point can we work together. So, well, I will show you the agenda. Let's see. Could you see my screen?
Yes.
Right. So, well, we will, we will talk about the measurement groups. And the first point, or the first questions, maybe some of you are thinking about, or mostly the new members, is about what is this working group about. So we will discuss a bit of this during the introduction that I will lead, and then we will move to the presentation of the speakers. I will present them before the presentation. So we will have 3 speakers that will talk with us, or will present what they were doing and what result they have. So I think it's going to be an opportunity to know what's happening around the world, and also to find opportunities of work together. The idea to the final moment of the session is to discuss about the main points that can be that we can focus on for the next year. So that's the plan for the day, and well, also to give moment to all of us to make an exchange, to make questions, and talk with all the speakers. So, well, about the working group, well, some of us know that it's a working group that it's moving around the data loggers, and some of us know. So the first idea is to tell you that this group try to work with other groups, maybe trying to develop new technologies focus on measurements. The idea of this group is to be able to measure the machines we work with. So we measure the small wind turbines, we measure the wind resource. We can have the result of these measures and make power curves, and also link it with other groups like market assessment, like educational group that we met yesterday, and also to maintenance. I think most of the presentation will be related to the technology group, because this group is very focused on develop data loggers, hardware, software, and try to prove them on file. So that will be the focus of this session, but it's important to remember that also this group work with trainings. So we can see the data loggers as an opportunity of making courses or trainings, practical trainings to teach people or specific people about the technology. And also it's an opportunity to test the installations and have information about the how the thing is going on. So we can maybe know if we have a problem and take actions, maintenance actions by making measurements. So that's are the ideas that this working group takes. And well, we will start the sessions with the first speaker. Let's see who is the first speaker. We have here for the first presentation, we have Anik Lehman. She's an electrical engineer in France, and she has been working with the software development of a data logger adapted for Pigot's turbines. Also, he's teaching support in the local Eolicol from September. So she's involved in also in the educational functions. So, well, Anik, I will show your presentation. Are you ready to talk?
Yes, thank you, Manuel, for the introduction. I can start speaking.
Okay, let me change the presentation.
I can show the
screen?
The screen, yes.
Okay, as you prefer. If you want to show the screen, don't worry. Go on.
Yes, I will try to do it right now. Or maybe, no. Yeah, can you share it maybe?
Yeah, don't worry.
Will be, yes.
Okay. Green button, ready. So here we go. Okay, you see my screen now?
Yes.
Yes, we can see it.
Right.
Okay, so as Manuel said, I was working from April to July in the project, which is called WinViewer. WinViewer, it's a web app that mainly takes into account the process of the data logging, but focused on the software development. And the idea is to connect with the sensor then send it to a microcontroller in the hardware, and finally be able to treat this data and analyze it in the software that I was developing in April. The main, you can go a little bit down, Manuel. Well, the main objectives of this project. Can you go to the next slide, Manuel, please?
Yeah, of course.
Perfect, thank you. Is as Manuel was explaining it before, is to be able to track the default method of building Pigot turbines which is also a way of control.
Anik, I think we lost you.
Yeah, I think Anik doesn't have a good connection. Could you listen us, Anik? Well, I think no. Let's take a moment to see if she's she recovered the good connection.
I guess I lost connection. Can you hear me?
Yeah,
Okay,
a bit.
I
Okay,
can hear
now
you
it's
now. Can you hear me?
yeah. Now yes.
Okay. Okay, so I was speaking about the last objective before passing to the system overview, which is being able, like the main objective of the data logger is to have the data in order to analyze it and statistics and get some conclusions out of it. The specific part well, here I present to you a little bit the system overview, which I was saying earlier. We start from the sensors, which will communicate with the microcontroller, and then through specific requests, API requests, they will be able to communicate with the server and then with the user. So maybe you can go ahead. Hello?
Yes, now we can hear you,
can you hear me
Anik, again? Yeah. Here we were.
I'm very sorry for the connection. It's really I'm in a place where there is not much signal. So the way we were working, it was through GitLab. So it's the project, it's online, and since it is still in the phase of development, it is open for participants, mainly from people in this group which will be interested to collaborate in the software system and maybe create an app that will be adapted through different firmwares and be able to have one point of gathering information from the different hardwares that are already developed. Regarding the technology stack, it was we started with Python and specific libraries that help to develop a web app, and the SQLite to treat the database, and the front end to have the visual part. It was in HTML, CSS, and JavaScript. So I joined some images down that you can see, which can give you a glimpse of the first version of the Win viewer. As you can see, maybe it's too little for you to see the details, but we are still in the developing phase. So the project now, the Win viewer, it can communicate with it can communicate with a server. By now, it's a local server, but the idea is to deploy this app. And maybe you can pass to the future work, Manuel, that it's right below. And regarding the future work, as I said, the point where we are standing now from this app is we can communicate in both sense. The user can send information to make some configurations of parameters, and the user can receive the data from the sensors. The idea now is to have a clear idea on how to deploy the app, and to do that we need to it will be very interesting to have a state-of-the-art phase, so we can look for maybe open source services, as I put in point number 3, to define the amount of data exchange, and finally also to think about the problem of isolated sites that have that don't have a connection. I guess it's the last slide. The rest is just if there are questions about it. So no, you can just stay in the future work.
Okay, sorry.
And yes, so there are some points that we can develop, that I can develop a little bit more when we'll be in the open space for exchanging. But the idea of this wind viewer is mainly to develop the software that will be able to link the user with the different firmware already developed in the data loggers. And that's it. If you have some questions, you can maybe ask them or wait till the end. Okay, I can speak a little bit. There were 2 versions: the skeleton version where we it was a sketch to the web app, and we were familiarizing with the database language. And then the alpha version is the one that you saw in the images, which is able to send information and store it in a database, as well as modify different parameters. And yes, and I guess for me, I let Manuel take the.
I think there is a question for you, Anik. It's about, is it possible or not to include LoRaWAN for as a communication link for the sensors? It's from Fritz.
Wait, Laura. Okay, so for the, I guess it concerns more the deployment phase. And I guess that's why I said the project is still in development, because the part in which I focused, it was really the coding part. And there's, if we want to continue with the project, there would be a global vision needed in order to make it, to apply these projects to the reality. So I wouldn't know how to answer if we can adapt it to Laura. Sorry.
Okay. Please send your questions by the Q&A or to be more organized. Let's see.
Emmanuel is asking if it's a funded project with a university.
The project I started with my university, but it's not funded. That's why I said it was from April to July, and then let's say the project finished. But I am still interested in developing the software if there is a working group. But it is not. It's not anymore funded by a university.
Okay, it's a good question because it could be interesting to talk with the fundraising.
Yes.
Just a small question from my side. Can it support as well encryption? Like, can the data that are streamed in the backend can be encrypted or not?
Yes, it can. For example, now the only function that is encrypted is a password for the user, but it is possible to create a secure database, if that's the question.
We have another question here. Jorge said, what is the cost of the data logger?
Okay, so actually I cannot speak of the data logger because the project that I am speaking about is the software. The Wind Viewer, it's not actually a data logger. It's just the software part that it's being designed and developed. So there's not a cost already because to do so, there will be needed a phase of defining how much data will be exchanged, the size of the server, and so on. So it's not the data logger itself; it's more the software part.
To add to the answer, Jorge, that's the next step of the hardware that Chiluz developed. So the point there, as Anik said, is how many data you want to change to upload. So the cost is on the server. Let's see.
Exactly.
If we have another question. Okay.
I guess we can leave the other questions to the ending, to the last part of this meeting.
Yeah, please send your question by Q&A, so then we can take it again and answer. So, well, many thanks, Anik. Thank you very much. We will continue. Okay, we will continue with Matthew. Are you? Let me present you, Matthew.
Hi there. Okay, great.
Let's see. Okay. Okay, Matthew will speak about his project. He's an electronic and electrical engineer on the UK. So he has been working with renewable energies since 2001, particularly in some project in Philippines with a local NGO. And then he started to work specifically with a measurement project in on-grid, on off-grid projects, also in solar projects. So he will tell us where he's what is he with working with. A bit salad. Please, Matthew, come on.
Great, thank you, Manuel. Hi everyone. It's I see a few familiar names here, so Hi, Lewis. Hi, Raphael. It's hi, anyone else that I've seen before. So I'm going to share my screen now, if that's okay. And okay, can everyone see that?
Yes.
Yeah.
Okay, great. So we've been through a bit of this and you've highlighted me. If anyone wants to get in touch, my emails are there, personal email and then my work email. So I wanted to review the work that I've done previously and how it links with other people's work that's been going on and how it links with wind empowerment. I've been variously involved with different successful and non-successful data loggers for a while. So I just wanted to go through the three main designs that I've worked on and also look at the work that I'm doing now and how it could maybe link with other people's work. So it's really interesting to see Anik's work there because I think that's really important to be in it. We need a nice interface between the loggers and the hardware that are being developed and software outside of things and be able to view it. It's a bit that I haven't really done much work on and I should have done lots more. So people in this group probably know all these things already, but I started off by wanting a very low cost way of discovering the wind resource potential in a potential site. So if you're installing big wind turbines, it's not a big deal to put £2,000 worth of data logging equipment and leave it there and get a year's worth of data. If you're installing a very low cost small wind turbine, it's generally not worth putting a data logger in to monitor the resource. You need to do a site assessment, but generally leaving expensive equipment there for a long time is not worth it. So we wanted to look at a much cheaper way of doing this and a way of much more low cost equipment. It might not be quite as accurate, but it will give us a good idea about whether that site is potentially suitable for a small wind turbine. Obviously, this is very important with wind because wind resource is highly localized. It can be very different even in very small changes of geographical changes. So being able to monitor in a number of places is good, especially for the Hugh Pigott design wind turbine, which is trying to be low cost and put in different locations. So, and I'm interested in, I think measuring and monitoring things over the long term is just what we should be doing because we need to prove that our systems are working and that they're actually producing a decent amount of energy and they're supplying the load that we're wanting it to supply. So back in, I think it was 2013, 2014, we started to look at doing a small low cost data logger. Needed to be low cost, reasonable accuracy. I didn't want it incredibly inaccurate. It needed to be reasonable. And one of the things was that it would all be open source so that anyone could produce their own. So the initial design that I worked on was shown in this photo here. It is, this was an SD card data logger based on an Arduino. So this is a little microcontroller that you can upload new code to. And I actually developed this board. The base board had been developed for another project to monitor water temperatures actually. And I built this additional board, which is the shield that goes on top. And this can take in anemometer pulses. So this was designed for pulse anemometers and a wind vane input. And it also could measure temperature with a thermistor. So it's pretty basic. I learned a lot. It did work. And all the data and the plans are all still available. The details are in that website there. I've actually just recently uploaded a bit more, so the GitHub's actually quite up to date. But I was not very good at code in those days. Also, this unit had no connection to the internet or any other data. It stored data to an SD card. You had to physically take the SD card out and analyze that separately. So I did write some code which analyzed the data with a CSV file. But if that could be automated, such as the work that Anik was just showing, that would be amazing. So it wasn't optimized. It still needed access to the SD card. It did work, but it needed quite a lot of work. But we did develop. We did a hands-on workshop to build a few of these. Then I produced another. Actually, there's two different designs. One was a kind of renewable energy data logger, and one was specifically a wind data logger. A few more advanced options. So we've got solar charging for a little lithium polymer battery, so it can then be left in location. The previous one was running on just big D-cell batteries that would run out after 6 months, whereas this is now with a solar input. But again, my code was not very good. It was better for measuring temperature, and there were some displays on it. And we had the Wind Empowerment Conference in Athens, where we all met up and met lots of people there. It was great, and saw the work that Gilou and Luis had been involved with. And at the time, mine wasn't really working well enough, and also there was no real funding for it. So I've got to admit, from about 2017, I have not worked on it very much. Again, the data, the files are all available. I use GitHub, but maybe I should be using GitLab. GitHub's now owned by Microsoft, I think. Yeah, the files are all available there if anyone's interested in seeing them. So what's happened recently? Well, a few things have happened. Firstly, there are much lower priced, very powerful microcontrollers available. For example, the ESP8266, people might have heard about. It's about $2 if you buy them in bulk. This is a Wi-Fi enabled microcontroller with you know, more than 100 times more storage than an Arduino. About $2 price, and then also the ESP32 has come along, which is pretty similar. It's just a little bit better than the ESP8266. So these actually have Wi-Fi built in, and they cost about $5. Utterly amazing, really incredible bits of kit. Also, one of the issues is what do you do with the data if you don't have any internet connection? So some of these kind of SIM modules, so wants to take a SIM card for your, like a mobile phone card. There's a couple of versions. There's the SIM 800, which is actually a 2G or GPRS connecting unit. It's about $5. And the SIM 7400 is 4G connection. It's about $20. On top of that, you will need a data card, so you will need to have mobile phone data. But what this has meant is, for very low cost, you can get a internet-enabled remote logging unit. I've recently taken a work as a part-time researcher at Loughborough University in the UK. I'm working on monitoring about 50 solar home systems and solar-powered sites, so not wind, but solar. And I've been tasked with producing loggers for those pieces of equipment. So we're looking at putting about 50 of these. They're going to be in remote rural Tanzania, so they probably got Wi-Fi, probably got mobile phone reception, very unlikely to be Wi-Fi around. So I've been working on a prototype. I actually have sat next to me, and look, the lights are on, it is working, taking data every 10 seconds. And I just thought I'd go through a little bit of this. At the moment, it's very much a prototype, but I will be aiming in the next 6 months to turn this into a full KiCad design. And I've done a lot of work on the code for this. That unit has been broken into 4 main areas. So there was a question about connecting with LoRa and LoRaWAN, and I think that could be just as simple as adding on additional unit that can do that connectivity. They're available, so you could use LoRaWAN. At the moment, mine has a Wi-Fi connection and a SIM 800 SIM card connection. And that sends data up to the internet, either through Wi-Fi if it's available, or through the mobile phone network if that's available, and that's stored in cloud storage. So that's where Anik's work would be on the cloud storage. I've converted this into 4 main sections. So we have the sensor unit. So this is what we're measuring different parameters. In my case, for solar home systems, I'm measuring current, voltage, power, and temperatures. This could also be wind speed, wind direction, wind turbine current. Any of those can be measured. And I'm designing a small board which actually uses an Arduino or the ATmega328 microcontroller. So that's a little board that just does its thing. It does the monitoring, but it does nothing clever. It just stores data. It just keeps data and averages it. So it measures the wind speed or it measures the power and the current. That is then connected to a slightly more powerful controller, which is the ESP32. This asks the lower power unit for data. It then sends the data either to Wi-Fi or through the GPRS connection. It also stores data to the SD card, and it also displays the data on an LED display. It's also got a real-time clock on board. The other bit that we need to think about is the web side of things, where the data is being stored and managed. That's very important, and I'll explain my options in a second. And we also have the power supply for the unit. So I'm designing this to work on solar or recharged by solar or recharged by a USB connection. So the firmware I'm trying to be much better at writing, trying to do libraries so it's much easier for other people to understand. There's 2 sets of firmware, one of which is for the sensor board and one of which is for the upload controller, I call it, so the heavy duty part. And it is actually all working at the moment and sending data, but it's not been tested in any depth. One thing that has been interesting to me, but it's not something that I've been doing, but one of my colleagues has been doing, but we're looking at sending this data and being able to do interesting things with the data. So this is where the side of things that Anik was talking about. So I'm actually using Microsoft Azure, which is a pay-for service where for Internet of Things devices. So you can send data to it. You pay a little bit of money for the data to be stored, but they have the big database. They store all the data and you can access it however you like. You can visualize it, you can see it. There's lots of other providers for this. There's Amazon Web Services, Google Web Services, ThinkSpeak, Adafruit.io, Open Energy Monitor. There's many others. These are really useful ones to think about. We're really good to have an open source way of doing this that's basically free or low cost. I want the data to be quite secure, and also it needs to be backed up and also quite scalable. So I'm going to be going from having 1 to 50 of these units, and all that data needs to be stored well. So I'm kind of paying money for someone else to deal with it. But it's got amazing potential. Once you've got the data, you can do some amazing things with it. You can start to do learning. So if you're monitoring a wind turbine, you're monitoring its power output compared to the wind speed. You can go, well, the wind speed's high, the power output's low, highlight, warn people what's wrong, send a message, send a text message. So my unit at the moment sends me a text message if the battery goes too low, which is quite annoying actually. But anyway, yeah. So you can do lots of interesting things. That's where the real interest is once you've got this data, what can you do with it? Just going forward, some future work. I've got a GitHub repository for the work that I'm doing with my Loughborough University work. At the moment, it's private. I'm in discussion with making this open. There are some issues with it because of the funding and the people involved with funding, but it hopefully will all become open. Like I say, I have this prototype next to me running, storing data on the little SD card, little display, and it aligns its real-time clock with the internet time. And also I use KiCad for doing PCB designs. If anyone needs to do PCB designs, it's a brilliant package. So there's obviously, if this was to be taken forwards in any way, I feel like this is some bit of hardware that could be useful, but I feel like the work that other people are doing on storing the data is where we need to look at how the teams interface and how all the different groups talk to each other, and we standardize how we communicate the different parts of the system would be really good. So anyway, that's me at a little ramble of what I've been up to. Hopefully that's been interesting. Please let me know if there's any questions at all.
Yeah, it was really interesting. Thank you, Matt.
No worries.
Let's see, it was a very quick resume, but really interesting. We have some questions here. Let's see. The first one, I think, is, most of the members answered by the chat, but the first question was, what means LoRa?
It's a good question, and I should know. It's basically a protocol for sending low. It's a low-speed way of sending data, wireless way of sending data. It has very long range, and I've slightly forgot what the acronym means, but you can get maybe a kilometer up to about 10 kilometers of wireless sending of data, but it's at relatively low speed. So you do need some kind of receiver, but you could potentially collect data from lots of places. It's also, you can send data with no cost, so you're not having to have a SIM card in every one. At the moment, my one uses mobile phone connection, so there's a SIM card in every one. Potentially, I could go to community, set up a LoRaWAN receiver, and within about 5 kilometers, all the loggers could talk to it for no cost, apart from maybe one monitoring system. So it's just another communication layer, like 2G, like 4G, but it's relatively low speed and relatively long range.
Okay, great. Then then we have second questions about for small wind turbines, wind gusts are important. That's true. It is possible to have a data every second.
So yeah, that's interesting. There's a few issues with data every second. You could store data every second onto the SD card, but you get huge files. If you want to send that data, then you're going to have the 2G, the SIM card running all the time. It's going to use a lot of power, so it's not very sensible. The way I do it is I'm actually taking either 1 minute, 10 minutes, or 1 hour averaged values, but I'm also looking at the minimum and the maximum. So that for those time periods, you look at the average and you look at the minimum and the maximum, and that gives you a bit about the gustiness. So if your maximums are very high, then you actually, maybe it's gusty, but your average is lower, then maybe that's gusty. But if average and the maximum are very similar, then that's quite consistent. That's the way I'm doing it. I'm sure there's cleverer statistical ways of doing it.
Okay, great. In which range of time did you said?
So mine is
average of what time?
So I'm actually recording data at 100 milliseconds. So it's taking in lots of data. Again, I'm talking about currents from solar power systems. So I'm not looking at the wind turbine ideas yet, but I'm measuring every 10th of a second. I'm measuring the current and the voltage and the power. I'm averaging that over different timescales. So I'm averaging it over 1 second, 10 seconds, 1 minute, 10 minutes. And then you configure the unit to read the data that you're most interested in. So you configure the unit with a config file on the SD card, and you say, I want to record 10-minute averages, or I want to record 1 minute average data, and it will store that data to the SD card. And then you also tell it what speed data you want sent to the internet or up to your online store, and that's totally separate to the SD card. So that could be, at the moment, I'm looking at probably hourly average sent up because of issues, but
okay, thanks, super clear. Let's see the next question. What would be the maximum pulling frequency?
So that frequency comes from the Arduino, the 80 mega 328 side of things. So it's actually, that's actually the slower speed unit. Like I say, I'm actually measuring that at 10 times a second. You could probably go a bit faster on there. I don't need to really. If I was doing wind turbine, wind speed monitoring, I wouldn't actually worry about averaging, like checking data. I would be measuring the number of pulses you get in a certain time. So you'd have an interrupt which would count. So you'd actually get every pulse that happens with the wind anemometer spinning round. And then you could also do things like average the wind direction over 1 second or 10 minutes. There's a lot of things you could do. I think the fastest you'd be able to get is probably about 1,000 times a second monitoring of current, but I never need that fast.
Okay. Then Rafa asks, is the 0.5 amperes 5 volts consumption continuous or only pulse on transmission?
No, so the I've actually managed to get the main board is in sleep most of the time. So it actually goes down to less than 0.1 milliamp when it's running. And the sensor board is also in sleep most of the time. It only wakes up to do the checks every 10 times a second. So actually the average current consumption of the unit itself with 10 minutes sending data to the internet through the GPRS thing is actually about 2 or 3 milliamps on average. So it's pretty low power. It could easily be powered by a solar panel, but it totally depends on how, when you turn on the SIM card unit to the GPRS unit, that takes a big boost of power. It takes up to about an amp, 1.5 amps, but for 10 or 20 seconds, and then it turns off and goes to sleep again.
Okay. Then
there is another question for you. Yeah, but from Rafael in Argentina, he's asking if you have tested Things board.
No, I haven't. I will look that up. I have the Things Network is a group of people that are doing LoRa band data monitoring and sending data, and it's I think free to use. Is that correct?
Yeah, you have two things actually. You have the Thing Network, and you have also Things board, which is different things. Things board is a platform as well that is fully open source, and it's online. It's a bit like ThingSpeak, but not related to MATLAB. So yeah.
Interesting. Yeah, that's really interesting. I will look it up. The board that I'm using is called the TT-Go T-Call, made by a Chinese manufacturer, but I can get them in the UK easily for $11 each. And that's got the microcontroller and the SIM card unit and a power controller. Utterly amazing for the cost, and $11. And it seems really robust and quite reliable and quite well made. So that's by LilyGo, but their products are open source within reason. They're not very well documented.
Well, going to the final questions. For both, for Anik and Matthew, Adrian asked if the works are doubles or they can be complementaries.
I guess my answer was not sent, but I tried to answer it by saying that, correct me if I'm wrong, Matthew, but the code that you developed is working and it's quite basic as you described it. So the idea would be to work together from now on the software part. Right, Matthew?
Very much so, yes. I think they're very complementary. So I think we were talking before that they've got the hardware design, and I've got I've got 3 different hardwares now. You've then got firmware, and then you've kind of got the software and online monitoring system. And so long as we're talking in the same way and we make sure we're working to the same goals, then I think all these things are complementary. I think all the work that the teams are doing can work together, so long as we make sure we're quite careful about how we each of the different bits talks to each other.
There is a last question, which is a general question. Can these data loggers can be integrated or connected with a charge controller? And would this be a smart thing to do or not?
It's a good question. I am trying to be totally independent from the rest of the system. So my units at the moment are designed to be totally independent. I think having some of the charge controllers you can buy have got some of these things built in. Generally, it's not open source, so maybe making it work with our systems will be hard. I think there's an amazing potential for the open charge controllers that are being developed to connect with this. And as long as we're reading the data from the charge controller, we could send it up. I think talking to the other groups that are developing that was also very important. So we work to a common goals. But yeah, I think the two things together, charge controller, which also monitors the system and monitors the resource, would be awesome, would be an awesome product.
Okay, many thanks, Matthew. Really interesting, and also Anik. So I think that the last questions we will retake it at the end of Guille's presentation. So many thanks to attendees for that pool of questions. So okay, we will move on with Guille. Let's see. Let me present you, Guille.
Okay.
Okay, Guillermo Catuogno. He's a professor at National University of San Luis. He's a researcher of CONICET. He had a doctor, and he's also an engineer on electronic. So he had been working with AEEE. So then he started to work with small grids, small off-grid systems, and well, start to collaborate in project that try to work with the open source technology and also with social impact. So he will present his work during the last 2 years, and well, we will see some points similar or with the same focus to Anik and Matthew presentation, and some new points related to the result of the measurements. So okay, please, Guille, let's go and tell me if you wanna, if you want me to share my screen.
No, I can share. Thank you, Manuel.
It works.
Can you see the screen? Yeah, perfect.
Yes.
Okay. Okay, well, hello to all the community of Wind Empowerment. Also, thank you very much, Manuel, for inviting me to participate in this session. As Manuel said, I work in academia, and listening, I have to confess something. Listening the both presentations before, excellent presentation from Anik and Matthew, I feel a little like I don't know if this sentence is common in another place, like a frog from another wheel, because I came from the control drives and power electronics, but also I think this is good for us to share these spaces, because we can learn a lot, also not reinvent the wheel. So share information and work together to better products. So the idea of the presentations is not is a case study and that we have been working the last year with the NGO 500 RPMs. This is rural school in my province, in San Luis. This is San Luis, as this is where it's in Argentina. We are in the centers, and the school is in the north of San Luis. The particularity of the school is that it's very difficult to access. They don't have electricity, only a diesel group that works 3 or 4 hours a day. So there was the only moment that they have connectivity to the world. So the idea there was install a system to provide 24 hours of electricity. We make a very traditional sizing of the microgrids, in taking in count the resource, the loads, and we make a Homer simulations. And finally, this was the implemented systems with 2 solar panels, with his regulator, a pivot turbine built by 500 RPM, a wind regulator, that is the wind empowerment regulator, 2 batteries, I think 150 amps, and 2 kilowatt inverter, and also the possibility to the school with a manual selector to come back to the old system with the diesel group, because we have like a 300 kilometers to the school. So if there is some problems, we have a lot of time to reach to the school. And also we develop a supervisory system that is the main focus of this presentation. So presenting the case study, now we are going to present the supervisory system. Is what very simple, consists, we install a PLC, a programmable logic controller, that acquire all the measurements from the microgrids, especially voltage, temperature, and current. This was connected via Ethernet to the router of the school. And then in our laboratory, we have a web server that recollect all these informations, storage in a database, and then from any client can check all this information. What was the features of the web server? It has to host a database, host the web server, make the communications with the PLC, and make all the management with the clients. So for this, we try to use all open software. The web service is running in Ubuntu. The package, we use this package that is XAMPP. I don't know if this is the pronunciation, XAMPP, that this include the Apache web server, the database MariaDB, and the PHP language for this web server. I think the last year we were working with MariaDB, then we have some problems. We have to change the machine, and now I think it's working with Heidi SQL, another database. And then we a code in Python make the routine to acquire the information from the PLC and also storage in the database. So what we program in the database, in the web server, Python make the routine to communicate with the PLC with the library of Modbus TCP. Then Python have to in charge to storage this data in the database, and then PHP have the work to prepare the information for the web client. And what we need in the client, we don't need anything. We need only just a browser. Well, and a little more specified the software use. We use Python, as I said, to that is running in the computer and acquire the information every 1 minute. We think that this time is good. We prove with a small time, but like Matthew said, the files were very huge, and also we don't want to collapse the Wi-Fi from the school because it's very poor. For example, you can see a YouTube video is just for mails or check some web page. But we can work a little faster. Well, then we have the exam that include the Apache, the database, and the PHP, and then some libraries. Well, the Modbus TCP for the Python to make the communication with the PLC. Then some libraries to the graphics of the web page. So this is the main board of the microgrid. Then in the supervisory system, we can see here the PLC. Then the sensor, there are LEM sensors. These sensors in principle are very expensive. This is a place that we can work to make a device cheaper. But we have a sensor for the batteries, the load, the PV and the wind generator. And also we have a current sensor for the dump resistor. And then when we check the temperature of the batteries. And also in the front of the board, we have a HMI that have basically informations. The most important information for the teachers of the people of the school is the voltage of the batteries. Then they have the minimum and the maximum of this value. So then they can see if the system is close to shut down or if the system is full. We have to improve a little and make like a special, like a semaphore, in order to they can manage the microgrid and the loads. Well, and here we have some results of the system working from last year, from September. And this is a typical day with solar, without wind. The pink curve is the wind current that is 0 this day. The blue is the battery current that is discharging during the night and then start to charge with the PV current at 8 a.m. until 6 p.m. And the brown is the load that is constant, that are the Wi-Fi and all constant charge. And at 9 a.m. start to increase the charge. And also we can see that the rural teacher stay in the school from Monday to Friday. So in the night we have also another extra loads. And this is the battery voltage. Here we have 10 days, and we can see in September there is some months that the wind is not constant, but we have a particular days of a lot of wind. So we can see this in this graphic. For example, we can see here is, for example, that the PV regulator is working fine, is set to 28.4 volts. And we can see that this controlling very well. Then, for example, here, the wind regulator from Wind Empowerment also is working very well, is set to 28.8 volts, a little up. And we can see that, well, this an advance and improve that we want to make here is make an integral, an average of this wind information because it's very noisy. But we can see that the system is delivering current to the dump resistor. The yellow curve are the dump currents. we can see, for example, in this point that we have 28.9 voltage, that 11 are approximately from to the batteries, and 6 amps are delivered to the dump resistor. And now another example that we can see are, for example, this day have a little wind and was a little cloud, and this day, the next day was totally cloud and without wind, and finally the third day the voltage reached 21 volts. That is the minimum of the inverter, so the system shut down, and then the system then start to charge, but this system is connected to the inverter, so when the teacher reset the inverter, start to measure again. So this is the system that is already working, but for the future works, we can see that the bottleneck of this system of what is not open is the PLC, that is expensive, very expensive, and also here we are not using like a PLC, we are using the data logger, the PLC, with an extra model that is not here with 6 ADC. So in the last months, we have to start to work with this that we call OpenWE, that have different functions. The idea of how it's born this device is because some request from 500 RPM, they want they don't want a regulator, they want a second protection for the wind turbine. They want an automatic brake, so in case if the regulators don't work and don't cut to 28.8 voltage, if, for example, in 30 voltage, this device works and short circuit the winding of the wind turbines and stop the wind generator. Start with these objectives, then we start to work and include different things, and we see that this device can work as a automatic brake, a regulator, wind regulator, and also a data logger. The two first functions are already working, and we have start to working for now, I think for the next year in the third one. So the idea is that when it's working, this device can, if we use as solar regulator, we can use to control the charge of the battery in the bulk stage, or in the another two phases of the battery. And if the voltage increase, we can with a relay output activate the coil of the contactor and short circuit the wind generator. And well, then the third function is the data logger, that I have one or two students that are working with some, try to replicate that we make with the PLC in order, and also I think make simple the system for this device. So a little more in detail, how is the OpenWE? It has a power connections to the dump resistor, to the batteries. It have some LEDs about the operations, and a lot of fault detection LEDs, because have a lot of potential for fault tolerance, and also some interrupters, for example, for switch on or switch off. And if also here we are not have the thermomagnetic, so if we want to brake manually, we can stop with an interrupter. And inside we can see it's based on STM32, and the communication is with a ESP8266. The regulator is, there are 3 AGVT. Here is one, but there are 3 in parallel. We have the power supply, the 2 outputs, relay outputs. We have temperature sensors that is syncing to the winding of the generator, also the batteries. We have, well, there is a ADC from the DC bus that is internally. There are C multipurpose digital inputs with different connections, 2 ADC multipurpose, and we have 3 that is focused on fault detections in the wind generator. There are rectified here, but if we don't put this rectifier, we can use as a multipurpose. This is in order to detect faults, for example, missing phase or something like this. Also checking also the temperature of the phases. So I hear or I see the presentation of Matthew. There is some student that start to working. The idea we are not decided yet, but the idea maybe for the next year, the new version work on ESP32, because also have the potential of the LoRa that in some cases we don't need it because there is Wi-Fi, but some cases where there are long distance and we only use this to supervise, not to make any control actions, maybe it could work. So there is a possibility to emigrate this system to an ESP32. And well, this was the presentation. Here are my contacts. Thank you again for the invitation. Well, if you have any question, I hope to answer them.
Okay, Guille. Wow, thank you very much. It was very clear, and I think it adds to the presentation before. So really interesting. Let's see. Let's take some minutes for some questions.
There is Anik that is asking something. She's asking, so did you create the server in your computer?
Yes, the server is on the computer, on a computer in the university that is use the server of the university.
Okay, then Adrian asked about the size of the turbine. It was 350 watts. Oh?
Yes, yes.
Then Alexis, about the presentations, we will upload all the presentations to the website of Wind Empowerment, as we say on the first day. But also, we invite you to use Discord, where we put all the links that Anik, Matthew, and Guille are showing in this group. So then we can chat there and get it easily and continue with the discussion.
Okay.
Let's see.
There is a question from Manuel, who is asking if the project is already on GitLab or GitHub.
The project is on GitHub, but there is no information inside. But because when we built this one is the first one, we find some problems in the pistas. I don't know.
The routing, yeah, in the tracks.
Yeah, in the tracks. So we are making these corrections, and in the next weeks we are going to update. Also, we use KiCad for this design, and also include all the models of the 3D printers. The idea, and that we are not going to upload, is the part of the data logger but this is only software. People can work on this, but the design we are going to upload in the next weeks. I can share then or put in the presentation to share to Wind Empowerment the link of the GitHub.
Okay, thanks, Guille. Another question from Rafael. Do the LEM sensors require 50 volts? How do you get those?
Yes, are from I think all are from there are 15 volts. No, there are 30 volts with middle point. So you need, but yeah, I remember. We need you to use same lamps or sense. You need both voltage, but in this case, we measure all positive measure DC measures, so we need only 15 voltage, and we take this voltage from the batteries with some I don't know if I think divided resistor. I think I don't remember.
Okay. Also, Adrian asked about the compensation of the temperature, if it is compensated.
Yes, the compensation is, the question is in the solar regulator, in the wind regulator. Yes, it's connected, and we don't measure the value if it's changing, but it's connected the sensors to the wind regulator.
Okay, my question was about the temperature of the battery and the change of regulation voltage according to the battery temperature.
Yeah, I understand the questions now. We don't have check, because at the beginning of the year we include the temperature sensors to the data logger. The wind regulator have the sensors, but we include the temperature sensors to the data logger. But then start the pandemic, so we can check now the temperature sensors to compare to the regulation, voltage regulation cut of the wind regulator. But this is interesting to compare if it's working, these compensations. Maybe it's a work for when the system is running again. Because at this moment this year, the school don't have activity.
Then you have the question from Jorge in India, who is asking what the cost of OpenWE.
I don't have I have a Excel with the cost. I don't have here, but this is cheap. And I think we speak about between $20 and $30. Maybe the more expensive things are when if you want to rectify the phases, all these components are a little cheap. Compared with the PLC that we use, is the 10% of the device.
Okay, great. Well, I think we don't have no more questions. So again, thanks Anik, Matthew, and Guillermo for the presentation and for the time. For me, it was really interesting, and I hope for that this too. So the idea before finishing the session is to open the talk to all of the attendees and try to discuss about what are the possible next steps for the group. I think some ideas start to appear. So the idea is to take maybe 10 or 15 minutes to discuss about it and invite all of the attendees that are not involved in the group to participate. So for these who are interested and involved, please come on. I will habilitate your phones or your talk. So let me see.
I remember something. That the question of the lamp sensors, I started thinking the lamp sensors have a power supply from 24 to 15 voltage, because you can use a resistor divider to connect it to a load. Only you a load, you can use for measure something. So have a power supply, a small power supply. That's a question from Rafael.
Okay, great. Let's see. Well, remember that now you are unmute, so please manage your computer.
I have one question.
Yeah, of course. Meanwhile, I continue habilitating the people.
So
Go
I
on,
have one
Anik.
question for Guille.
Yes.
Okay. It's about how, if you could explain, how do you calculate the size of the server? For example, when you show the picture of the 1 minute measure.
The size of the server?
Yes, for the database, sorry.
Okay, yeah, these are the questions that I am afraid being not from this. I don't know the specific answer to this question. Maybe I can put in contact with some professor that help me with this develop.
Okay, that can be interesting. Thank you.
Okay, well, to use this few minutes before going to the next session, I would like to first to discuss about or maybe to think about the first point we were thinking on was the state of art. I think that this meeting was useful to see where we are, where this world is in. So if someone else is working with data loggers and measurements and have another developments, please let us know so we can be in contact and also make contact. That's the first point. I guess that maybe, I don't know if Luis is here. Yeah, Luis is here. Luis, you sent me that you have a state of art of the measurement development around the world. What you can send me about this, if you are available to talk.
I am always available to talk. Are you guys available to listen to a child screaming in your ears? That's a different story. Now, we had an intern that did the state of the art on the kind of systems like Facebook. Actually, Jean can talk about it, so you don't have to listen to my child scream. And we have a PDF with the state of the art. We can share that with you.
Okay, I think it would be useful, so we can attach it to our group and take a view. That's the first point, I think. About the second point. So, sorry, before moving on, I will say that I invite you to collaborate in Discord to that point. So if anybody have another information, it is very welcome. And if anybody don't know how to use Discord, please contact us by the mail or by the chat, by the WhatsApp. The second point we were discussing about was about the functions, trying to find a complementary work, as Adrian said, or ask. So the main idea was to discuss if it is possible to define some functions that all the devices require. So I would like to discuss a bit about that point. What do you think about this?
I've got a couple of points on that, if it's okay. So I think we have to be careful to describe the firmware based on that's going to be actually in the machine. So and then also the server side of things, the kind of software. We need functions, we need libraries for both of those kind of ideas. So I feel like within the firmware, we need kind of standardized ways of taking wind results and analyzing them. And then we also need standardized, maybe it's like a JSON script, JSON list, which is a standardized way of us sending data from our hardware to a server implementation. And it could be the work that Anik's doing. It could be a server that people have implemented on their own hardware, or it could be going to a online server system. But I think if we standardize the way that the data is formatted, then we can have choices, and we can just decide, do we want a local server that we're going to maintain? Do we want to pay some money for someone else to maintain a server? But if it's all in the same way, we can then utilize the same code from same people, but maybe with slightly different hardware. Anyway, that's my 2 pence worth.
From your experience, Matthew, which is a way of communicating from firmware to software? So to define it briefly.
So I'm not the best person on this at all. The way that I am doing it with my work is that we create a small JSON string, and we use an HTTP GET request to put data into the server side of things. So there's a standardized way of having a name of a channel, and then the data, and I'm standardizing with this average, the minimum and the maximum. They're always contained within the message. And you can send, with my one, you can either send one channel or you can send 12, a whole load of channels all together. I think we need to have quite a good discussion about what's best. I'm certainly not the best person at all to know about that. So I'm sure there's some software folk that would have a much better idea.
Okay, but it's a little bit more clear. That's actually the same way we are working now with a wind viewer in a JSON string with an HTTP GET request. So it would be only to order which goes first with which code, and yeah, but it's the same way.
That's great. Yeah, I think some of these we can't have it the same for absolutely every situation, but so long as we are very clear about how the data has to be formatted, we can have little libraries in the firmware that create it for your server. For the wind viewer, you have a library which just gets your data and puts it in and does the correct request. I'm using Microsoft Azure for this, so I also have a library for those functions, but it's very easy for me to change between the two. One thing I did find was with GPRS, it's a quite slow connection, and it didn't work the same as having the Wi-Fi connection. Wi-Fi connection was very quick and easy to do. The GPRS needed these HTTP GET requests.
Okay. Guille, do you have an opinion, or do you think about this possibility for the data logger you are working on?
Yeah, I think it's very interesting to standardize all the program of the data logger from the system that we implement. And also when the PHP is answering some query, the informations also travel in a JSON format and adapted to the client. For me, it would be in the future include in this group some of my colleagues that work specifically in this topic, because they can apport more in these develops. And also, as we see our first development from the rural school, we was very happy because it works, but is very inefficient in some aspect. So the idea is to improve in the hardware and in the software. This is the idea.
Okay. Well, I see that there we have a point of to work on, maybe to try to make more connection after the conference. Again, we can use Discord or we can use another tool, but I think it is interesting to be in contact before making more advanced, because it can make us to gain some time. So, well, this was the main idea of the session. I really like it. Thank you very much for all of you. The idea now is to take a break, and be prepared to the Jones and the technology season. So again, thanks you very much for the time and the presentation, and also for you for being here and take the time. So, okay, if there are no more questions or no more ideas to discuss about, I will take that 2 points that we said and move to the Discord, and also try to be in contact with the people involved and use the information between us. So again, if somebody else is working on another data logger or other related things, please let us know.
Also, a quick technical thing. We will share around the link for the next panel in the chat and also on the Discord, so that everyone can join in 20 minutes for the technology working group session.
Okay.
Brilliant. Thanks, everyone.
Bye. See you.
Okay. Bye-bye.
See you in 20 minutes.
See you in 20 minutes. Cheers.